Have Japanese scientists just found a way to slow aging from the inside out? Let's break it down in simple English. A team at Osaka University studied a protein in our cells called AP2A1. As we get older, AP2A1 goes up and our cells change shape and behavior in ways that scream, "I'm old." Here's the wild part. When scientists turned AP2A1 down in old cells, those cells started acting young again, smaller, more active, less stuck. That's like taking a cluttered room and suddenly making it clean and energetic again. This wasn't a face cream. This was cellular. What exactly does AP2A1 do? It helps control traffic in the cell, like a gatekeeper for moving stuff in and out. In aging, that traffic gets jammed and cells grow big, stiff stress fibers. Think tight ropes running across the cell that make it bulky and slow. The researchers showed AP2A1 is tied to those stress fibers. Lowering AP2A1 loosened things up and many old cell signs faded. In young cells, cranking AP2A1 up made them age faster. That's why some people call it a switch for cell youth versus cell age. Now add a second player, a lab drug called IU1. As we age, our cells' cleanup crews, systems that chew up junk proteins, slow down. IU1 blocks a brake, an enzyme called USP14, so the cleanup can go faster. In animal and cell studies, IU1 helped maintain protein quality control and sometimes even boosted lifespan in flies. Imagine giving your cell's garbage disposal a tune-up so it clears gunk before it causes trouble. That's what IU1 aims to do. Put together, the idea is simple. Turn down AP2A1 to help old cells act young and use IU1 to speed up cellular cleanup. Better structure plus better cleanup equals cells that function more like they did years ago. This is early-stage science, but it points to a future where we target aging at its roots, not just the wrinkles, but the wiring. Why should you care? Because aging cells drive the problems we feel. Slower healing, weaker muscles, foggy thinking. If researchers can safely flip that cellular switch and clear the junk, it could support healthier hearts, brains, and joints as we grow older. It won't make anyone immortal, but it could stretch the healthy years, the time you feel strong, sharp, and independent. But let's stay honest, this isn't a take-home treatment. AP2A1 changes were shown in lab models, and IU1 isn't a pharmacy drug for people. We need human trials to prove safety and benefits. Still, this research is a big step toward true health span science, treating aging itself, not just the diseases that follow it. Bottom line, scientists at Osaka University uncovered a protein switch, AP2A1, that can push cells toward young or old. Pair that with IU1 to boost cellular cleanup, and you've got a promising 1-2 punch against aging at the cell level. Keep your eye on this space. It could rewrite how we think about getting older. Medical note, don't try to source IU1 or copy any lab methods. For real-world healthy aging now, sleep well, move daily, eat whole foods, and see your doctor regularly. The science above is exciting, but it's not a DIY plan.